Welcome everyone. In today's video, we're going to talk about limits epsilon delta definition. It might look really abstract at first sight, but after using the definition a little bit in limit problems, trying to prove some limits, and of course, we will try to explain the definition here today, I think you will understand it. And of course, we will record some problem solving videos about this topic after this video. Good. Let's start by reading the definition. For every epsilon greater than 0, there exists a delta greater than 0, such that absolute value of x minus L is lesser than epsilon whenever absolute value of x minus A is lesser than delta. Okay, good. It's not an easy definition to understand, of course, but first of all, this is saying that limit of fx as x approaches to A is L. When I say this is not true. It is mathematical, but I am missing something, right? Because saying x approaches to A and fx approaches to L is not that mathematical. So I want to use this definition to show what I'm trying to say. Good. To do that, of course, we need to understand the definition. So I need to I need to draw the graph of fx. Let's say this is our fx, right? And this is our A, and this is our L. Good. There's a limit here. It doesn't matter if A is, like, at this point, fx is defined or not, but alright, good. How am I gonna use the definition? For every epsilon greater than 0 and delta. Okay, good. Such that fx minus L is lesser than epsilon. Okay, let's try to understand what this is telling to me. This is lesser than epsilon. If I take this out of absolute value, I'm gonna see that I am getting epsilon, and this is greater than negative epsilon. And if I add epsilon L to every side, I am getting L plus epsilon. Good. So basically I have an L plus epsilon here, and I have an L minus epsilon here. So therefore, I get something like this, right? All right. Let's do the same for the other side. Absolute value of x minus a is lesser than delta. If I take this out of the absolute value, x minus a is going to be between delta and negative delta. Now we add a to every side again, a plus delta. So of course a plus delta is somewhere here and a minus delta is somewhere here. Therefore, the thing I did gave me an area like this, right? So what is this? This is like this because the epsilon and delta I picked here, as we can see, is too big. If I made epsilon and delta closer to L and A values, you see my limit is, I'm getting closer to the limit, right? So if I get the right values for the delta and my epsilon, I am gonna get my limit, and I will say this limit is this, right? This is the logic behind of it. I tried to explain it like this. But of course, to understand it better, we need to see this on examples. Let's do one example in this video, and we will continue to make like some more problems in other videos. Prove limit of 2x plus 5 as x approaches to 2. What is this limit? 2 plus 2 is 4 plus 5 is 9, right? Prove it. Really simple. Prove. The question is really simple. Proving is it that simple? Depends. If you understand it, if you can use the definition well, it's pretty easy, but if you cannot, you might struggle, right? Let's copy this. We need the definition, right? Okay, it did not take the delta, but it's okay. Let's have our definition next to us. So lesser than delta. Delta. Good. Now I have my definition with me. Everything is ready. Only thing I need to do is using the definition. But of course, how am I gonna do that? So I will follow it. And this is my definition, right? Definition. What is it starting with? For every epsilon is greater than 0. Okay, I'm gonna start with that. Given any epsilon greater than 0, and now I have a delta greater than 0, we choose delta greater than 0 to be something, right? What is my delta? My delta can be epsilon over 2, something like epsilon over 3, 3 epsilon over 2. I don't know, but I know one thing. My goal is finding the delta. How am I gonna do that? By using the other part of my definition. I will keep this part blank for now until I figure out what my delta is. Let's continue. What is it saying? Fx minus L is lesser than epsilon. Okay, what is my fx? 2x plus 5, right? And minus L. What is L? 9. Oh, right, good. This is lesser than epsilon. Whenever x minus a, what is my a? 2? This is lesser than delta. Okay, the thing is, I am not gonna touch this part, okay? Think it like a game. I am not touching the delta. My goal in this game is finding the delta. I need that delta. How am I gonna find it? I will use this, I will play with this, and I will try to get the delta from here. Let's see how can we do that. This is equal to 2x minus 4, and that's lesser than epsilon. And if I take this to the two parentheses, I am seeing that this is lesser than epsilon. I can take the 2 out, right? So this is x minus 2 lesser than epsilon. And if I divide every side with 2, x minus 2, absolute value of this, is lesser than epsilon over 2. As we can see, I managed to get the same thing. Therefore, I found my delta. From the beginning, my delta was epsilon over 2. I found it. Good, now I can say this is epsilon over 2. Good. Is my proof, is this the end of my proof? No, it is not. One more step left. Proving that the epsilon I found works. How am I going to do that? I did not touch this. Now I'm going to use this. Okay, let me take it to here. Let's use another color for it. So this is the second part of our proof, right? This was the first part. Oh my god. This was the first part, and this is going to be my second part. Hmm. Hmm. Okay, how am I gonna do this? I know that absolute value of x minus 2 is lesser than delta, and I know my delta is epsilon over 2. X minus 2 is going to be lesser than epsilon over 2, since these are equal. I multiply every side with 2, I get epsilon. And I can clearly see that we get to this point. What did I start with? 2x plus 5 minus 9. Are these equal? Yes. 2x plus 5 minus 9 is lesser than epsilon. I got to the same thing as well. Therefore, I showed that the epsilon that I found is working. Of course, we have to finish the proof. Okay, we did these, but we need to write what we did. So you'll say, therefore, what was it? 2x plus 5 minus 9 is lesser than epsilon. What am I doing is I am using this part of the definition, right? I'm saying that this works. I started with epsilon is greater than 0. We choose a delta. Good, I found the delta. Now I say this is lesser than epsilon whenever x minus 2, absolute value of x minus 2 is lesser than delta, that is required.